Hello everyone, welcome to this video in our statistics series. Today we are going to explore a problem involving normal distributions, specifically focus on combining two random variables and understanding their covariance. This question is based on a past exam questions in the university. So I guide you through the solution and show you how to handle case where the variables are correlated. So let's dive in. So let's start to the problem statement. So here what we are given is explore a normal distribution, a means of 10 and a variance of 3. Y is also for a normal distribution with a means of 15 and a variance of 8. So the question states that x and y are positive correlated with a correlated coefficient of 0.6. So what is the probability distribution for the four question 1, 2, 3, 4? So let's start with the first question. So the first question is the sum of x and y. Okay, and then to begin with to solving this question, let's outline our approaches. So we need to use two important concepts. One is to find out the means of the combination of the variables. We simplify as or subtract their means as required by operation. For variance is a bit more complicated, and especially since x and y are correlated, so we will calculate the variables, the variance by adding the variance of x and y, and then including an adjustments for their covariance. Okay, so we solve the case one by one first. So first of all, we need to consider the coefficient value 0.6. So what is this? Actually, this one we can call it rho. Okay, so the rho is equal to p x y. Okay, and then equal to covariance x y divided by variance subscript x and the variance subscript y. Okay, so so according to the question, we rho is a 0.6. So we will find that covariance x and y equal to 0.6 times variance subscript x and the variance subscript y. So we write down the definition. So now we can start to solve the question one. So so we will tackle the sum of differences of x and y. So we because here is the first one, we need to find what is the probability distribution of x plus y. Is we first is to calculation the variance first. Variance x plus y equal to variance x plus variance y plus 2 covariance x y. Okay, so very simple. So because the variance of x is 3 and the variance of y is x, so we 3 plus x plus 2 times 0.6 multiple variance subscript y and the variance subscript x and variance subscript y. So we finally, so we need to use the calculation here. Let me see. Okay, so the answer should be, this is a 1 plus Okay, enter the answer should be 1.699. So finally, we found that x plus y is follow. Sorry, yeah, is follow the normal distribution. This is a 25 because tens plus 15. This is 25, and then the variance here is 16.899. Okay, this is the answer. So question 2. So we need to the means of x minus y is found by subtracting the means of y from the means of x. So also it's simple. That's minus. So we expand the formula into this form. Okay, because y here y is positive because if you keep the constant from outside, if they have to make the square. So even you have a negative one, you after you mix square, you will positive. So so that's why here I write positive here. So same here is minus. Minus the covariance x y because it's minus here. Y here is minus. It's not positive because it's minus because here is x minus y. So you have to minus the covariance. So and then we continue. So need to calculators first. So the answer should be e plus x. So here is minus. This is minus. Okay, the answer is 5.121. And then the next step, we found that the next step is x minus y follow the normal distribution. Here is a minus 5 because 10 minus 15 is minus 5, negative 5. So so here is 3.121. Okay, so this is answer of the question 2. So the next question is question 3, 3x. 3x is a simple, just because 3x variance 3x is equal to 3 by variance x equal to 27. So the 3x is follow the normal distribution. This is a 13 because 3x here we times 3 times 10 times multiple 3, and then here is 27. Okay, the last question. The last question is, let me see, is variance 4x plus 5y. Okay, it's correct. So simple. We need to keep the constant out of the variance. So this is 16. This is a 25, and then plus the variance, and so then the covariance is x y. So here beware we have to aware that because we have the constant here, so when we make a covariance, when we calculate the covariance, make sure that the constant need to keep outside of the covariance. So okay, so we continue to that is a is 3 plus 25 18. Okay, so let me use a calculator. 36526. Okay, so finally we got the answer. So 4x plus 5y for the normal distribution 1115. This how to find the 115 is easy because this part is a 10 plus 5 15. So here we can find that this is a 75. This is 14. So the final answer is 115. Okay. So and the variant is 365.576. So this is answer. Okay. So to what the thing up here, some key takeaway. The first is that when combining normal distribution calculation, the mean is straightforward, but the variance requires specific attention when the variables are correlated. And remember, the formula of the covariance formula is a covariance of x and y is correlation uh, coefficients times the standard derivations of the x times the standard derivation of y. So and then last point is by applying this principle of means and variance adjustment, you can handle any linear computation of the normal variable. So I think this 3 point is important. How to understand how to understand the key point, how to do this question, and understand this 3 points. We will prepare you for the similar problems on combining normal distribution with correlation. So that is today's session. Be sure that to practice similar problem to reinforce your understanding of the statistics concept. If you found this video helpful, please like, share, and subscribe to stay updated with more content. See you in the next video. Bye bye.